Good morning, everybody. My name is Trevor May. I am the VRF and duct-free split technical specialist here at Standard Air and Lite, and we're going to be covering a VRF product overview with a specific focus on an overview of the two-pipe and the three-pipe, or what I like to refer to as the carrier and Toshiba carrier VRF systems, and what applications are best suited for them, and also what are the differences between a carrier versus a Toshiba carrier system, and when are we more likely to use one or the other. So as we dive into VRF, there have two primary system types, and typically this is where the confusion comes in with VRF, is assuming that all VRF is heat recovery, when in fact, there are heat pump VRF systems. So first and foremost, with the heat pump, these are going to be traditional heat pump systems. So these are going to be units that can either heat or cool, but cannot give you that simultaneous heating and cooling that the VRFs are typically associated with doing. So it's certainly important to make sure that you specify between whether you want a heat pump or whether you're looking for that heat recovery with that simultaneous mode. So now we know what the heat pump is. We know that that's all heat or all cool, whether we have one unit or whether we have 25 units. Now, on the other hand, and the other system type that we have is what we typically associate with those VRF systems, which is the heat recovery. Okay, so these are going to be those fan coils, cassettes, high walls, ducted units that can have that simultaneous heating and cooling need. And that's done in terms of a branch box or a flow selector, which essentially is comprised of a solenoid valve, a tube and tube heat exchanger, and some form of control wire that's connected to it to be able to communicate from the indoor unit to that specific port to open up individual solenoid valves to allow hot gas into a coil and return liquid, and allow liquid to come out and return suction gas, depending on whether we're in a heating or whether we're in a cooling mode. So there are two primary VRF system types: heat pump, which is all heat, all cool, just like any traditional heat pump or split system. And then we have what the technology is typically associated with, which is the heat recovery style of systems, which is that simultaneous heating or cooling. And the great way to tell them apart is if your system has a FS or a flow selector box or a branch box, then you know that that system is a heat recovery system. If your system only has two pipes, then you're pretty sure it's a heat pump system. Okay, now there are some variances depending on what style systems. For example, our system to the bottom left hand of the screen, which is the carrier system, is a two-pipe heat recovery system, which can be a little confusing depending on what you're used to looking at as far as three pipes versus two pipes, which is one of the reasons why I don't like the designation between three-pipe and two-pipe VRF, because it can get confusing on which one's a heat recovery and which one's a heat pump. So primary components of our carrier or our Toshiba carrier. Now in this particular case, this is going to be a primary example of a heat pump style system. So this is all heat and all cool. So of course we have our outdoor unit, which is going to house our compressor, our electrical section, outdoor coil, and outdoor fan motor. We have our interconnecting refrigeration pipe that's going to connect to multiple or single indoor units on there. Now, in this case, we have our cassette, but we have the ability to facilitate high wall units, ducted units, vertical air handling units, floor console units. There's a wide variety of options that we have to meet various spaces. Okay, and then finally, on that indoor unit, we need to have some form of control, whether that be the wired control that we see on the screen, whether that be a wireless form of control, or just a remote sensor on the wall. Good rule of thumb on these: you have to have some form of wired control on the indoor unit, or you have to have something centrally controlling the indoor unit. So there needs to be some form of control on these indoor units. They cannot just operate off a remote sensor without some hardwired or centralized controller. Now we look at a carrier heat recovery system. Now you can see here we have our outdoor unit, our indoor unit, and controller. Now you notice the difference between the previous slide for a Toshiba carrier heat pump and a carrier heat recovery is, on the heat recovery, we have what we call on this system an MDC, which is a multi-port distribution controller. Essentially, this box is what allows us to be able to simultaneously heat and cool and allow each individual zone to have a call for heat and a call for cool, and be able to recover that heat or to be able to recover the cooling throughout those zones and be able to distribute it as needed basis to be able to take care of multiple spaces without a mode conflict between a heating and a cooling call. Okay, on the Toshiba carrier systems, this box is called an FS box, or a flow selector box. Okay, you'll see a lot of different acronyms. Other manufacturers, we use terms such as branch box. Carrier, in this case, uses MDC. Toshiba Carrier uses FS. They're all pretty confusing acronyms because there's a lot of different determinations on what the actual device does, what it's called. But for the terms of what we're trying to understand here and just make it simple, they all are really doing the same thing. Now, the only difference between this system and a Toshiba Carrier system is that I talked about before, this outdoor unit has two pipes. Okay, so this is a two-pipe heat recovery. So the difference between a Carrier and a Toshiba Carrier system is going to be that the Carrier system has two pipes that leave the outdoor unit. That separation process into three states of refrigerant happens in the MDC on the Carrier system by use of a gas liquid separator to create hot gas, liquid, and suction. Obviously, your three states of refrigerant. That process on the Toshiba Carrier system happens in that outdoor unit by use of opening up a solenoid valve to bypass the condensing coil and send hot gas directly on the hot gas line to our flow selectors. So when we talk about differences, the separation or the creation of three states of refrigerant just happens in different places. On the Carrier two-pipe system, it happens in what we see on our screen here as our MDC. On the Toshiba Carrier system, it happens in the outdoor unit, which is why we have three-pipe heat recovery system for there, and why we can have a two-pipe heat recovery system on our Carrier VRF outdoor. Okay, it's just a little bit confusing. I mean, there definitely are some intricacies in understanding what is heat recovery and what isn't. But in a basic nutshell, this is pretty much what we're working with as far as a Carrier heat recovery system is concerned. We have an outdoor unit. We have our multi-port distribution controller, which we know now has a gas liquid separator to create those three states of refrigerant. It has a brazed frame heat exchanger to help subcool that liquid refrigerant so we can get greater piping distances. And it has solenoid valves to control or essentially act like stoplights in a traffic intersection to control refrigerant flow depending on what indoor unit or units need them. And then, of course, we still have some form of indoor unit that's connected by refrigeration piping, and then some form of control, whether it be wired, wireless, or centralized. Okay, now we talk about the Toshiba Carrier heat recovery system, and we look at this as an outdoor unit, an indoor unit, some form of control. And just like on the two-pipe or the Carrier system, the Toshiba Carrier system has the FS box, just like I talked about before, except now we're not calling it an MDC, we're calling it a flow selector, but it is essentially doing the same thing. It's governing that refrigerant control and how it's actually going to the indoor units. So it's like a governor in the system. If the system doesn't need refrigerant, the solenoid valves aren't going to open up. If it does need heating, temperature call for heat or for cooling, it's going to open up the appropriate valves, whether that be hot gas, liquid, or suction. Okay, but essentially they're doing the same thing, and that is the crucial piece of a VRF heat recovery system that allows you to simultaneously heat and cool without a conflict. But essentially, we're working with the same thing. We have an outdoor unit, a flow selector box with a tube-in-tube heat exchanger to subcool liquid refrigerant, solenoid valves to open or close or govern that refrigerant flow. The only difference from the previous slide we just talked about is that this box does not have a gas liquid separator because, remember, like I said on the last slide, the outdoor unit has a solenoid valve that opens up and bypasses hot gas that normally would be sent to the condenser to be boiled or condensed down to a liquid. Now creates three states of refrigerant at the outdoor unit: hot gas, liquid, and suction, which is why we have a three-pipe heat recovery system, because that process happens at the outdoor unit, unlike on the previous slide where that process happened in the MDC. Okay, again, there are a lot of variances to it. I know it could be a little bit confusing, but hopefully that gives you a better understanding of where that heat exchange or where that process of creating three different states of refrigerant happens on a Toshiba Carrier, and then of course a traditional Carrier heat recovery system. So let's take a look at the three-phase product line that we have. So first, we're going to start with the Carrier VRF system. So we have our heat recovery in three different unit sizes. This will vary based on capacity. But the nice part with this, if you look at the slides up there, they come in a single base row application, which means we're not twinning or having triple modules together, which require twinning kits. Okay, with the twinning kits, there are more rooms for error, and there also is more brazing joints on the system, which could be more potential leak areas. Okay, so the nice part is we eliminate the twin kits. We eliminate the time that it takes to actually join units, whether it be a twin or a triple configuration. With the single base rail, we only have two pipes that are hooking up that are going to our flow selector or our MDC, 1 point single point power and single point communication, because it's all one unit feeding in a single base rail versus having a dual or a triple configuration. Okay, now on our heat pump, we do have single, dual, and triple configurations, and that's just how the product was laid out between the heat recovery versus the heat pump. Now, the heat pump will range from 6 to 36 tons, and the heat recovery will have 3 different unit sizes: a small, medium, and large cabinet. These are available in 208 233 phase and 460 volt 3-phase, and they'll range from a 50% minimum, 150% maximum connected capacity ratio. Okay, and these utilize our inverter-driven scroll compressors, unlike the Toshiba carrier systems, which use the rotary style compressors. Now, on our heat recovery style systems, we have our single, twinned, and triple module. Excuse me, our heat pump systems are single, twinned, and triple module on there. Now, again, the max that we could have is 3 outdoor units to reach our maximum tonnage on there, which would be 432,000 BTUs. Okay, and again, this will range from 72 all the way up to that maximum of 432,000 BTUs of capacity on a triple module. Now, the heat pumps, just like the heat recovery, are available in a 208 233 phase and 460 volt 3-phase application, and will range from a 50% to a 135% connected capacity ratio. So when we talk about differences between the heat pump and the heat recovery side, we have a little bit less connected capacity ratio than we do on the heat recovery, which was 150, unlike the heat pump, which is 135. And then, of course, just like the heat recovery option, we're still using our inverter-driven scroll compressors. Now, let's look at operating temperatures as far as the heat pumps are concerned. So in the cooling mode, we'll range from 5 degrees all the way up to 125 degrees. And at that 5 degrees on there, we're going to give you 80% of that system's nominally rated capacity. Okay. And in the heating mode, we can go all the way down to -5, all the way up to 64 degrees. And again, at that -5, we're going to give you 80% of the rated capacity at -5. Of course, this all varies based on combinations that we have hooked up to the outdoor unit. And then, of course, whether we're dealing with a 6-ton system or a 12-ton system or a 20-ton system, and how we have those units twinned, tripled, or whether we have a single module, will essentially dictate how much coil surface area that we have, and also how many compressors that we have in that system to add redundancy and also low ambient heating capabilities. And then again, these are just rated performance ratings. The systems will run below this. Of course, they will naturally derate, but these are guaranteed performance ratings. Now, on the heat recovery side of things, we look at the cooling mode as being able to go down to 5 degrees all the way up to 125 degrees. And at 5 degrees in the cooling mode, we're going to give you 70% of that rated capacity. And in heating mode, we're rated down to -13 all the way up to 64 degrees. And at that -13, we are also going to give you 70% of that unit's rated capacity at -13. Again, 100% capacity will determine whether you're dealing with a single base rail, a mid-size base rail, or a large base rail unit, or a small, medium, or large cabinet. Again, it all depends on coil surface area and the amount of compressors that we have in the outdoor units for redundancy and also low ambient heating capabilities. But on average, if we look at a 6-ton system at -13, we're going to give you 70% of that unit's rated capacity at -13. Now, as far as the indoor units go, we have a wide array on the carrier VRF system. So we have our cassette style units. So if you look from left to right, the first unit that we see on there is going to be our 2x2 cassette. And the unit to the right of that is going to be our 3x3 cassette. Both of these units were developed obviously for ceiling grids to be able to recess up and sit flush in there to blend in with the space. They can also be used in industrial applications by the use of all thread and unistrut to be able to suspend them centrally in the room and to give that nice exposed look. We also have our high wall style unit, which most people should be familiar with by now. Above that, we have our new introduction, our one-way cassette. which I have a specific slide to go over in the new fan coil introduction on what advantages that gives us as far as an indoor unit product line. We also have our vertical air handling unit styles. So this is going to resemble a residential furnace. This could also be great for commercial applications that have existing furnaces that they're looking to upgrade. And on top of that, add other equipment to help better condition that space. We have our floor console, which personally is my favorite unit on there because it's dual purpose. So that's going to be not only a floor console, but that could be dual purpose as an underceiling style unit to be able to, one, be in the space, but not take up floor space as a floor console and mount directly underneath the ceiling. And it does have that nice adjustable louver to dictate how that airflow can be put throughout the space depending on what's needed. We have our floor console recessed to the right of the dual purpose unit. That is going to be good for applications, obviously, that have a supply that come right up by an outside window to help create that barrier between the outside, of course, and the inside of the space. Okay, we have our ducted style units, so our low static, medium static, and high static units on there. Low static, we're going to look at being about 0.2 inches of static pressure on there. Mid static is going to give us about 1/2 inch of static pressure. And then finally, our larger size high static unit will range from 0.8 up to 1.1 inches of static pressure. Now, of course, that's definitely something that we need to take into consideration when we're applying the unit and how many takeoffs that we can facilitate to make sure that we get proper air distribution throughout the spaces we're trying to serve. And then the last unit I want to cover on here would be our outside air unit, which essentially acts like a makeup air unit. Okay, it helps temper and supply that neutral air to the space. One thing you want to note with the outside air units that it will not handle raw outside air. So that air needs to be warmed up or pre-treated to a certain degree, typically around 32 to 33 degrees minimum, to be able to be fed inside of that outside air unit. And then the outside air unit, of course, can handle the rest, bring it up to a neutral air temperature and be pumped into the space, all part of the VRF system. And of course, this would be for applications where maybe we cannot facilitate a dedicated outside air or a DOAS unit. Certainly an option that we have and something to consider. So all in all, we have 11 different indoor unit types. They'll range from 5,000 all the way up to 96,000 BTUs of capacity. Again, that depends on what type you're dealing with. That doesn't mean that the 2x2 cassette has 96,000 BTUs. Of course, it has a small footprint, so it's limited on its capacity, unlike the 3x3 cassette, for an example. But of course, that'll vary depending on what type of unit that you're dealing with. They're all available in a 208, 230 single phase application. And most, if not all of these have integral ventilation and condensate lift mechanisms. So for example, the cassette style units have outside air knockouts that can have outside air ducted directly into that fan coil. However, that outside air does need to be pre-treated prior to sending that air into the unit because it cannot handle raw outside air. Those units also have built-in condensate lift mechanisms. And we put the emphasis on lift because it's just designed to lift the water out of the unit into a secondary pump or into a drainage system where that condensate can be drained out. It's always important to make sure that you reference the appropriate installation manual to know your maximum lift rating, as these do not have check valves built into them. And if that unit does shut its pump off after a cooling cycle and you are over the maximum lift rating, you certainly run the risk of overflowing the drain pan and causing a water leak situation in the space, which of course is never good. Now, if we look at the high wall style units and the under ceiling floor console unit, these do not facilitate any outside air knockouts to introduce fresh air into the fan coil, and they also do not come with a condensate lift. They do have accessory style pumps that can be added to the units, but they do not come with them from the factory. The low static, mid static units have built-in condensate lifts, and they also have knockouts that you can introduce round duct into the unit itself, or you can mix in fresh air at the return, of course, because it's a ducted style unit. The only thing, just like we had with the cassette style units, is you need to make sure that that outside air is pre-treated prior to entering it into that fan coil. The only difference between the low statics, medium statics, and the high static unit is that the high static unit does not have a condensate lift that comes with it. So you will need to specify an outside pump, such as like a little giant, a Sourman, something external to the unit to manage that condensate if necessary. Okay, so let's switch gears here. We talked about the Carrier product line. Let's switch over to the Toshiba Carrier product line. So you'll see on here, both on the heat pump and the heat recovery, we have the single, dual, and triple modules. So across the heat pump and the heat recovery line, we have 21 different unit sizes that'll range from 72,000 all the way up to 456,000 BTUs of capacity. These are available in a 208, 230 three-phase and 460-volt three-phase application, and these will range from a 50% minimum to a 130% maximum connected capacity ratio, with the ability with factory support to get up to 150%, of course, with factory support and engineering approval based on the application, to make sure that we're not going to dig a hole for ourselves and apply more indoor unit capacity than we actually have for the outdoor unit. And unlike the carrier system, we are utilizing 2 rotary compressors per outdoor unit on the Toshiba carrier system. That adds that nice redundancy, a little bit better low ambient heating capabilities, and then a nice technology that will balance the runtime between compressors. So for example, if we were to look at compressor 1 running from 8 to 12, okay, the system realizes that that compressor has ran from 8 to 12. And now it's going to say, hey, you know what? I'm going to run that second compressor from 12 to 5 to get equal runtime, which in turn generates a longer lifespan and equal runtime for those compressors versus a non-traditional inverter-based system. Now, let's look at some of the heating operation ranges for our heat pump style system. So in the cooling mode, we can go down to 14 and all the way up to 122 degrees. In the heating mode, we can operate down to -13 and then all the way up to 60 degrees. And at that -13, or in the cooling mode at 14 degrees, we can provide 70% of that system's rated capacity at -13. And again, just like the carrier system that we were talking about prior, this all depends on the connected capacity and also the unit configuration, whether we're dealing with a single, dual, or triple module, coil surface area, and also the amount of compressors that we're dealing with for that low ambient heating capacity. But as a rule of thumb, like I stated before, if we look at a 6-ton system, it will give you 70% of that system's rated capacity at -13 and just about 100% at 5 degrees. But again, it all varies on the type and configuration of equipment that you have. Now, on the heat recovery side of things, we're looking at the same exact thing. Cooling mode is 14 degrees, all the way up to 115 degrees. And in the heating mode, we can operate down to -13 still, and then all the way up to 60 degrees. And again, just like with the heat pump system, our heat recovery system will give you that 70% system capacity at -13 and roughly 100, right about 5 degrees. Now, with our indoor units on the Toshiba carrier system, just like the carrier style, we have our cassette styles. So the top one is going to be our 3x3 cassette, or our larger cassette, and then our 2x2 cassette, or our compact style cassette. Again, these were developed for the ceiling grid applications to be mounted up flush, or you can use them industrial style applications with the use of all thread and unistrut to centrally mount the unit for a nice exposed look. We have our ducted units, so our low, medium, and high static ducted units. And just like on the carrier style systems, low static unit's going to be just about 0.2 inches of static pressure. Mid static is going to be about 1/2 inch. And then our high static unit will range from 0.8 to 1.1, depending on how we need to configure that. We have our high wall style units, which again, we should all be familiar with. Our under ceiling application, which just like on the other system that we just talked about, is dual purpose. So it can act as a floor console, and it can also act as an under ceiling style application. And we also have our vertical air handling unit, which is a great residential furnace replacement if we're looking at a single phase heat pump, which we'll get into here in a second as a direct replacement for a furnace. Or if we're looking at a commercial application, this is a great replacement furnace if the existing application has it, or if we're looking to apply that into the space. And the nice part about this as well, this has backup electric heat packages that we can put in there in case we get into a worst case scenario where we can still provide heat. So all in all, we have 9 different indoor unit types. They'll range from 7,500 all the way up to 96,000 BTUs of capacity. And then of course, just like we talked about on the carrier style system, it all depends on what type of unit that you're working with. So that doesn't mean that the compact cassette has 96,000 BTUs. It all varies based on what type of indoor unit that you're trying to apply. These are all available in 208, 230 single phase applications. And again, just like on the carrier style system, they have integral ventilation and condensate lift mechanisms on most of the models. So the cassette styles have the outside air knockout, and the condensate lift. Of course, with any outside air into the fan coils, that air needs to be pre-treated. And just like we had prior to that, the low static, medium static, and high static ducted units on top of the vertical air handling unit can all have outside air mixed in at the return. And of course, that air needs to be pre-treated. So let's take a look at the Toshiba Carrier single phase product line and also the Carrier single phase product line. So we have a Toshiba Carrier model. We have our straight Carrier single phase VRF heat pump. And then we have our Toshiba Carrier single phase heat recovery, which is a great application for light commercial, which does not have access to three-phase power, or larger residences looking for that simultaneous or that heat recovery capability. So with the Toshiba Carrier single phase VRF heat pump, these are available in a 3, 4, and 5-ton capacity range. We're able to give you 100% heating capacity at 5 degrees for our 3 and 4-ton models. And on our 5-ton unit, we're going to give you 80% heating capacity at 5 degrees. We have the ability to connect up to 9 multiple style indoor units on a 5-ton system. On a 4-ton, we can connect 8, and on a 3-ton, we can connect 6. So again, it depends on the tonnage for the maximum connected number of indoor units. We offer up to a 21.5 SEER cooling efficiency and up to an 11.5 HSPF heating efficiency. Okay, and we offer a total system piping length of 591 feet. Now, on the opposite side of things, when we look at the Carrier single phase heat pump, these are also available in a 3, 4, and 5-ton capacity range. We'll offer up to 18.6 SEER cooling efficiency, up to a 10 HSPF heating efficiency, and the ability to connect up to 9 multiple style indoor units on a 5-ton system. And again, just like on the Toshiba product line, these will depend on the tonnage of outdoor units. So the 3, 4, and 5-ton have a different number of total maximum connectable indoor units on that one outdoor unit. And we have a total piping length of up to 492 feet total. On the Toshiba Carrier heat recovery system, we have the ability to have a single 6-ton module like we see here, or we can gang or have a twin configuration for 2 6-tons to get up to 12 tons of available capacity for a single phase power application. Okay, we have the ability to connect up to 25 indoor units. This is a true 3-pipe heat recovery system. So we think back earlier to the slides that we went over. This has that separation process or allows that simultaneous heating or cooling in the outdoor unit, which is why we have 3 pipes on the system: hot gas, liquid, and suction. And again, this has that high performance outdoor units with the inverter driven rotary compressors. And we still offer 2 per outdoor unit, not only for redundancy, but also to increase low ambient heating performance. And just like the 3-phase product line, we still have a total system piping length of 3,281 feet total to work with. So we certainly have flexibility on residential and light commercial applications that we can look applying this equipment to. Okay, so let's switch gears and let's go ahead and take a look at the 2-pipe product. So with the heat recovery 2-pipe product, we have our small box, medium box, and large, just like we talked about before we did the generalized overview on here. Now you can see on here on our 6, 8, and 10-ton modules, we have 1 compressor per outdoor unit, and depending on what tonnage we're working with will dictate the maximum connectable number of indoor units. Now, as we step up through a 12 through 20-ton, we're going to move to our mid-box module, and you'll notice on there that the compressor amount increases, obviously because we have more tonnage that we're trying to facilitate. Okay, and of course, as we step up the tonnage, that maximum connectable indoor unit number does raise with the tonnage as well. And then finally, as we go through our 20 through 28-ton applications, we'll move into our large box module, which again adds another compressor and more connectable indoor units. Our maximum connectable indoor units on one centralized outdoor unit, for example, on a 26 or a 28-ton unit, is going to be 64 units. Now, again, that is only the tonnage that will facilitate that many indoor units. It all depends on what tonnage that you have for your maximal connectable indoor units that you can hook up to a Carrier VRF system. Now, of course, too, as we add more compressors, and we also add more coil surface area, we also gain a better low ambient heating performance. So like I stated before with the D rates on there, it ultimately depends on what configuration and also the connected capacity of indoor units versus outdoor unit tonnage that we have. Now with the heat pump style systems, you'll see here with our 6, 8, and 10 ton, we still offer that one compressor per outdoor unit on the single module. Now with the 12 ton is where we start stepping up with the dual compressors in there. And of course, just like on the heat recovery, as we increase in tonnage, our maximum number of indoor units that we can connect to that one centralized outdoor unit does increase as well. But the nice part with that 12 ton, as we increase with the amount of compressors, we increase our low ambient heating performance as well. Now, as we step up between our 168,000 BTU on there or our 14-ton unit, all the way up to our 288,000 BTU or 24-ton unit, you'll see we have a different configuration of compressors. So we see we have 2 compressors all the way up until we reach 22 tons of capacity. Then we start adding 3 compressors on that 22-ton system. And on the 24-ton system, we have 4 compressors. And again, maximum number of indoor units that we can connect on that twin module does raise as well. And you'll see twin modules, more coil surface area, more compressors, better low ambient heating performance. And then finally on our triple module, which is going to be from our 312,000 BTU all the way up to our 432,000 BTU or our 36-ton outdoor unit, our number of compressors start to increase right around our 32-ton, which we end up with 4 compressors. On our 34-ton unit itself, we'll end up with 5 compressors. And then, of course, on our 36-ton compressor or 36-ton outdoor unit, we're going to end up with 6 compressors. So obviously more coil surface area, more compressors, more low ambient heating performance. And then, of course, as we reach our last 2 tonnages on there, which is going to be our 34 and 36-ton unit, our maximum connectable indoor units will be 64. Okay, but again, that all varies on your outdoor unit tonnage. And just like we talked about on the heat recovery side of things, the D rate on these units will depend on what configuration of outdoor unit that you're working with and also the connected capacity that's to that unit itself. So looking at our MDCs on there, so we know that our MDCs are responsible or comprised of 3 main things. We know that they receive superheated gas and subcooled liquid. They allow for that specific indoor unit to be in either a cooling or a heating mode. And they distribute the amount of refrigerant to the indoor units based on that individual heating and cooling demand. And that command is sent via a communication wire from that indoor unit to its MDC or selector box. So if we take a look inside of one of these selector boxes, one of the biggest advantages with the Carrier 2-pipe systems is that these service boxes, as far as solenoid valves go and actual being able to work on the box, are fully serviceable. This is something that our competitors cannot claim because the inside of this box is insulated, and that is to prevent the box from having a drain on it. Well, from my service background and the way that I look at things, I would much rather sacrifice having a drain and trying to figure out where to drain so that I can go and work on this box and be able to replace individual solenoid valves instead of having to leave extra port on a box to unpipe a unit from a port that, let's just say, has a failed solenoid over to another port that's working. So that's one of our biggest advantages that we have with the Carrier 2-pipe system is a fully serviceable flow selector box. So in this case, when we break this box down, there's that gas liquid separator where we create those 3 states of refrigerant, so hot gas, liquid, and suction. Our braze frame heat exchanger, which subcools that liquid refrigerant so that we can get greater piping distances in the cooling mode, and also generally speaking, because this box is typically centrally located, and then we pipe out from that central location, so we certainly need to facilitate long piping runs. And then finally, we have our individual solenoid valves. So we have hot gas solenoid valves, liquid solenoid valves, and suction solenoid valves. And of course, depending on what indoor unit needs what, is how those valves will open and or close. But basically, this is what our MDCs or our flow selector boxes are made of. Gas liquid separator, braze fan heat exchanger, individual solenoid valves. Now, with our indoor units on the Carrier VRF system, we look at having our compact cassettes, our 3x3 cassettes, our high wall style units, and then also our ducted style and floor console style units. So all in all, we're offering 11 different indoor unit types, and they'll range from 5,000 all the way up to 96,000 BTUs of capacity, of course, depending on that indoor unit's model. Again, the compact cassette does not range up to 96,000 BTUs. They're all available in a 208, 230 single phase application, and we have integral ventilation and condensate lift mechanisms on most of the models. So for example, like we talked about before, the compact cassettes do have built-in condensate lifts. However, they have a maximum lift rating that we need to make sure that we do not exceed. Otherwise, we run the risk of overflowing the drain pan, which the unit will leak water. And then, of course, integral ventilation on the ducted style units can be mixed in at the return. And the cassette style units do have knockouts where we can put round duct and duct outside air directly into the fan coil. Of course, the rule of thumb that we always want to make sure that we pre-treat that outside air, as those coils, both the ducted style and the compact cassette and 3x3 cassette, cannot handle raw outside air. Now, specifically on our one-way cassette, which is a new product introduction on there, we can range from 5,000 all the way to 24,000 BTUs of capacity. So of course, with the one-way cassette, we have that one directional airflow with multiple fan speed. And a unique feature with this one is we have a knockout for outside air, of course, that has to be pre-treated. But for sizes 15,000 all the way up to 24,000 BTUs, that we can facilitate piping in some outside air that is pre-treated to the actual fan coil itself. Okay, and just like all of our other units, these are utilizing those flared refrigerant pipe connections on there. But definitely something to keep in mind, and something that we're constantly expanding, is trying to, have a comprehensive indoor unit product line to fit multiple style applications. And this one-way cassette is just further proof of the different indoor units that we have and can facilitate for multiple applications. Now, as far as wired controllers or controllers of the VRF system, we have a few different options on here when we talk about local controllers, centralized controllers, and then also building management. So if we look from left to right, we'll start with our wireless controller. Okay, all of our indoor units are compatible with this wireless remote controller. However, not all of them come shipped with it. The only one that does come shipped with that wireless controller from the factory is the high wall style unit. Now, if we move on to our wired controllers, we have our programmable and non-programmable types. Now, depending on what application that you're looking for, whether you have a centralized controller, may dictate whether you want a programmable or a non-programmable. And 9 times out of 10, these are typically the local controls that we're going to see mounted on the wall, not only because that they offer control of the mode, the set point, but they also offer an insight to be able to troubleshoot the system. That's how we get into the system to do addressing. And then, of course, you can set up your time, your clock, and everything else, any schedules that the customer wants to set on those as well. So they are multifunctional on how we can use them. Now, for our centralized controllers, if you can see on the furthest right to the screen on here, this is our most popular style centralized controller. Essentially, it's like a giant iPad on there, and it's very user-friendly and intuitive. Essentially, it offers a centralized point that we can get into the system to monitor and record a bunch of different data that we can see in the system from a centralized point of view. And this typically becomes handy on larger style systems with more than 20 or so indoor units, where we don't have to walk through multiple floors or throughout the entire space to get an idea of how the system's performing or where the issues are at in that particular system. Now, with our wired remote controller, pretty much straightforward. The only difference between this and the programmable one is that this one is not programmable. So we have our on and off, we have our mode set points, we have our swing features, and then of course we also have the ability to get in here and do addressing and see inlet and outlet coil temperatures, the amount of amps that that particular indoor unit is drawing, return air temperatures. So there's a lot of different functionality on top of being a local unit controller. With our programmable controller, same exact operation. Now you can see there's a little bit difference as far as actual physical makeup of the wired controller, but essentially they're offering the same thing. The only difference on this wired control is that it does have the ability to be programmed to set up for a schedule depending on what the customer or customers would like. With the touchscreen centralized controller, again, this can get up to 384 indoor units per centralized controller. You have all of your individual control operations such as mode, set point, fan speed, and also the ability to name each room depending on how you want to customize that system, and also error code generation for each or all of the indoor units that are on that system that may have an error. We can also set this up and integrate this into existing fire alarm systems. So if you want this to trip off or throw a code if something trips a fire alarm with an existing HVAC ducted system. We also have a digital input and digital output that we can configure depending on how you want to use this to send out control signals or trip alarms. And we can also set up alarm notification via email. If something goes down, you can have the appropriate people be notified to make sure that someone is aware of the issue and that they can address that issue as soon as possible. So it really is a nice central control option on there. And typically this is the central control that we like to see applied. There used to be a predecessor to this that was non-touchscreen. In my personal opinion, I always thought it was a little bit difficult to deal with. This touchscreen is essentially like an iPad, and it's really easy to navigate through. It just takes a few times of actually going through it to get used to how everything flows throughout it. Now on this touchscreen controller as well, you can see here, it takes all the information from our outdoor units, broadcasts to the central control. We require 120 volt power supply. So typically where you're locating this, you'd want this by a power outlet to plug in. And then of course we have the ability on here to customize the IP addresses to match whatever your on-site IP address is to send out to a modem so that you can remotely monitor via IP address to log into the system at a local supply, or you can also set it over Wi-Fi so that you can log in and see the system at any given time to be able to see if there's an error, to make changes, or just to inquire about the units to see how they're performing. Another option that we want to talk about with the carrier VRF system is going to be our VRF ductless interface on there. So this interface is utilizing our centralized controller that not only can connect our carrier VRF system, but it can connect carrier ductless all on one centralized controller, which really makes controlling and monitoring the systems simplistic as possible because we have one centralized location that we can monitor issues or monitor performance instead of walking the entire building itself. Okay, but certainly something to keep in mind, especially if you have a project that's going to have a mixture of VRF and ductless throughout the space. This is certainly something that you'd want to consider, and in my opinion, take advantage of to be able to monitor multiple style systems that are not just VRF. Now, as far as upper level controls goes, we have our BACnet over IP interface on there, and this is to be able to tie into an existing BACnet system. And all it's doing is just taking the carrier VRF language or protocol and converting it over into BACnet protocol, which we can then broadcast to the existing control system. And with this, you get your temperature set points, you get indoor unit temperatures, operating modes, error codes, different schedules that you can set up through the actual interface itself. And then you also get your outdoor unit, which is your mode, outdoor temperature, and then any associated error codes on that outdoor unit that are active, and also a history of them.